Hi, this is Sue McBride, and in this PowerPoint we'll be talking about types of statistical studies based on the text Statistical Reasoning for Everyday Life for our Math 157 class. Our learning goal here is to understand the differences between observational studies and experiments, and our objectives to do that was you'll be able to designate whether a given situation is observational or an experiment, and also recognize the key issues in experiments, including selections of treatment and control, placebo effect, and blinding. One of the assignments that you have is looking at ethics and research, and this is one of the main components when you're doing statistical studies is make sure you're doing those things properly and with taking care to make ethical decisions. So that's one of the reasons that is an outside assignment that's actually very interesting for you to see the rules associated with that. All right, so let's see. First, we need some definitions as usual. So by now you've had a lot of definitions and you've seen that statistics really does require you to know the vocabulary. So make sure you're studying what we've done so far to make sure it makes sense to you, as we will be using those definitions as we go forward. Okay, so first off, a subject of a study is the people or animals or other living things or objects chosen for the sample. A lot of times if they're people, they're called participants, but subjects are the thing of interest that you're going to be choosing for your sample. We have two basic types of studies. One is called observational, which is what it sounds like. You just observe the characteristics of the subject, but you don't influence or modify. So you literally stand back and observe. Like if you're a teacher, most things are observational studies. You stand back and you watch the students and you see what they're doing and record those observations or measurements. You're not attempting to influence or change. In an experiment, though, researchers will apply a treatment and observe its effects on those subjects. So observational, you're not attempting to influence. In an experiment, you're doing a treatment to see what effect it does have. So would this be observational or an experiment? Asking a poll, that's just going to be observational. You don't attempt to change anything, you're just trying to get some information. So what are variables? We have a whole lot of definitions associated with variables. In algebra, it's the value that the number takes on, usually x. In statistics, we have a whole different way of talking about variables because they're real life actions that are happening. So whether they are observations or experiments, what we call a statistical study is measuring variables of interest. What are we interested in measuring? All right, so a variable then is any item or quantity that can vary or take on different values. Variables of interest are the items or quantities that the study is seeking to measure. What are we interested in finding out? Variables of interest. Now, we do have a totally different name for, in algebra, you have the x and the y axis. In statistics, we have what are called explanatory and response variables. Cause and effect may be involved. So an explanatory variable is a variable that may explain or cause the effect. So it's the first thing. A response variable is the variable that responds to change in the explanatory variable. So you start with the explanatory and then you see what response you get. So what would those be if a poll in which people are asked for whom they plan to vote in the next election? So the variables of interest would be the candidate's name, since people have to choose who they plan to vote for, and proportion of supporters would be the fraction of people polled who plan to vote for a particular candidate. Since there's no cause and effect, we don't really have to decide which one is explanatory or response. But the variable of interest is the candidate's name, and we're interested in finding out who the supporters are, what fraction of those people polled supported that candidate. All right, so observational studies here. So the most familiar of those on which data are collected all at once or as close to that as possible. So in other words, you don't want to start your study one year and finish it another. We want to try to get it done pretty quickly all at once, so we don't get what's called a confounding variable, which we'll talk about shortly. All right, so two variations on observational studies can also be done. A retrospective study, you just pull up data from the past, like when you go look up official records in the Office of Records, etc. That's retrospective or case control from the past, retro. A prospective study or longitudinal one is going up into the future from groups that share common factors. So types of observational studies, you can either observe what happened in the past, that's retrospective, or prepare to observe what's coming in the future, a prospective. So you want to know whether children were born prematurely. Do they do as well in elementary school as children born at full term? So what type should I do? Well, since I want to go look at the past, this would be a retrospective study. Would be things you could go look at past births and compare those with current elementary school performance and compare those from the premature to those born at full term. So a retrospective study. All right, an experiment. Now we all know what an experiment is, but in order to know if it's making a change or not, we have to have what's called a control. So we separate the groups that get the experiment into the treatment group and the control group. The treatment group gets the treatment, the control group does not receive the treatment. In most cases, you want to choose those by random selection from an available pool of subjects. So you have to choose each group randomly and who gets which group. So here we have a study dividing college students into two groups. One listened to Mozart or other classical music while being assigned a task, and researchers found that those listening to the classical music performed the task slightly better, but only if they did the task within a few minutes of listening to the music. If they did it later, they performed equally. So what was the treatment and what was the control and treatment groups? So my treatment was the classical music. It's the thing we are applying to our groups. The treatment group was those who did listen to the music. The control was those who did not. Right, now, why would I need to have these controls? I mentioned earlier this idea of confounding variables. So if someone is confounded, they are confused or things are fuzzy. So if you have a confounding variable, it mixes up stuff so much that we can't separate. We can't figure out what caused what. So variables that lead to that kind of confusion are called confounding variables. Everything gets all mixed up, so we can't tell what caused. So when we assign our treatment and control groups, we want to try to make sure we don't have confounding variables. So one thing we're going to do is select our groups at random, make sure that the subjects of the experiment are assigned to the treatment or control group at random. So either one has equal chance of being assigned to either group. Also, we want sufficiently large groups. In statistics, more is better. Now, more isn't always possible because more costs more money, but you want to have the largest group possible based on your budget, etc. So make sure treatment and control groups are both sufficiently large so they're unlikely to differ in a significant way. We'll talk about this significance a little bit later in the semester. So the only difference between the groups should be one's getting the treatment and one does not, as far as possible. And they should be pretty much the same size. All right, now I know you've heard of a placebo effect. My favorite placebo for small children is a Band-Aid. We all know the Band-Aid doesn't really make it that much better, but boy, as soon as you put it on, the child feels much better and you can give them a kiss and send them on. A placebo effect. So a placebo actually lacks any active ingredient of a treatment being tested, but it looks or feels like the treatment, so the participants can't distinguish whether they're receiving that placebo or not. So when we're talking about an experiment, if you're giving a medication, both groups have to receive some kind of medication. So the treatment group would get the real one and the control group would get the placebo. A placebo effect refers to the situation in which the patients improve simply because they really believe they're getting a treatment, like the Band-Aid. Oh, that made me feel so much better, but it doesn't really, it just has a psychological effect. So even though participants should not know whether they belong to the treatment or control group, for ethical reasons, it's very important that participants be told that some of them will be given a placebo rather than the real treatment. So in other words, they don't know which one they're getting, but it has to be made clear to them, ethically speaking, that they know they're not all getting the treatment. It's a 50-50 chance as to whether they're getting the treatment or getting the placebo. So in decades past, sometimes they told them they were receiving the real one, but really gave them a placebo. So we know this is now unethical. So as you're working on the research ethics, this is one of the things that you would be looking at. So should researchers be allowed to do that if they don't, or use the results if they don't meet today's ethical criteria? That would be an interesting thing to discuss. Now, the Hawthorne effect is also an interesting effect. It occurs when treated subjects somehow respond differently simply because they know they're part of an experiment, regardless of the way in which they're treated. The Hawthorne effect gets its name from the fact it was first observed in a study of factory workers at Western Electric's Hawthorne plant. One of the things that in my situation, the Hawthorne effect happens is when you go in to observe a group of children, sometimes they start behaving differently simply because they're being observed. So that's why when you're observing, you have to try to be careful and stay out of the way because they know something's going on. So be careful of that Hawthorne effect. People can respond differently just because they know they're part of something, whether it's an experiment, an observation, etc. Now, experimenter effects are slightly different. When a researcher or experimenter somehow influences the subjects through factors such as facial expressions, tone of voice, attitude, etc. So in other words, if the experimenter knows who's getting the treatment or the placebo, they may, be looking sad or happy, something that lets the person in the experiment know, I bet I'm not getting that treatment versus, oh, I bet I'm getting the treatment. It makes a difference in the results. So be careful of experimenter effect. One of the ways we can deal with that is through blinding. So blinding in experiments, you have a single blind if the participants don't know whether they're members of the treatment or the control group, but the experimenters do. So in a double blind, neither the people in the group, participants, nor the experimenters know who is who. So if possible, a double blind is the best way because then you don't have any possibility of that experimenter effect. All right, and lastly, a meta-analysis. Sometimes you've got a bunch of prior studies. Not all of them necessarily have the same results. So a meta-analysis, meta just means large here, considers these studies as a combined group with the aim of finding trends that were not evident in any one study. So, they do lots of different things on different cancers. One of the ones they've been working on is how soon should you get a mammogram. They keep coming up with different studies with different groups. So a meta-analysis would take all the past studies and put them together and look for trends that way to see if they could find an overriding characteristic. So a meta-analysis. All right, let's take a few examples from the text so we can, this is the type of thing you'll see on your homework. So if you can get out your textbook, look on page 28. As you know by now, I don't do the instructions with all of them. It just takes up too much work. Ouch. Sorry, bumped my elbow. Let's see, types of study. For number 9, I did do the directions. We're supposed to state the type of study. Be as specific as possible. All right, so here we're looking at quality control. So Apple selects a simple random sample of iPhone batteries. the voltage of each battery is measured. Right, that would be observational, and it's not prospective or retrospective. It's just simply an observation. They select them, they measure them, they look at the measurements, they're done. All right, so this is a simple observational study. Number 14, texting and driving. Here we have a study of 2,500 fatal car crashes, identified those that involved drivers who were texting and those who were not. All right, this is observational again. It's not an experiment, but it is retrospective because these are crashes that have already happened. So they're pulling up prior observations and taking a look at it. So this is a retrospective observation. Let's see, down on number 19. In a study on the effects of magnets on back pain, some subjects were treated with magnets while others were given non-magnetic devices with a similar appearance. The magnets did not appear to be effective in treating back pain. So this is just a simple experiment, and we have a study of the effects of magnets, so others were given non-magnetic. So it's just a simple blind, it appears. Now they could figure out if they had a magnet or not if they tried, just by going and seeing if whatever they had was magnetic. So it would be hard to do a blind on this one. It's just a straight experiment. Number 20, we have power lines in cancer. Hundreds of separate individual studies have been done to determine high voltage and overhead power lines. Does it increase the incidence of cancer? Interesting, we've been house shopping, and our real estate agent, as soon as she sees those big power lines, she says, well, I don't think it does, but I have so many people who won't buy those that she doesn't recommend you buy it because it might not have good resale value. Interesting. So here we have a summary based on many previous studies. So this one will be a meta-analysis. Concluded there is no significant link. So it's just, we find out these things get reversed all the time. So according to this meta-analysis, there is no significant link. And we'll leave it at that. All right, let's flip over to a different type of question. What's wrong with this experiment? So here for 24 and 28, identify any problems likely to cause confounding variables and explain how they could be avoided and any problems that might affect the results. All right, so for our aspirin trial, phase 1 of a clinical trial designed to test the effectiveness of aspirin in preventing heart attacks. Aspirin is given to 3 people and a placebo to 7. Well, first off, I'm sure you're thinking already, wow, only 3 people and 7? So first off, there aren't enough people to start with, and second, you've got more than double the people getting the placebo. So the sample is a big problem on that. It's too small, and it's not even on the number of people who are getting in the treatment and control group. Things that you could do to fix that, obviously, would be have a much bigger sample and make sure you have even numbers in both. And you would also want to be careful of the age that you're giving, the age of the participants. You wouldn't want to use children, and young folks aren't that likely to have a heart attack anyway. So you would want to have a certain age group as well as a spread of men and women, etc. So you would have to set this one up pretty carefully and definitely have better sample sizes. All right, what about paint mixture? In durability tests of Benjamin Moore and Sherwin-Williams paints, the researchers who evaluate the results know which samples are from each of the 2 different brands. All right, so this could definitely have confounding variables because if they know which brand it is, it just may affect their results. They might prefer one over the other, so they automatically, they've already formed an opinion. So a better thing to do here would be to do a blind where they don't know which sample is from which. Okay, that's pretty much section 1.3. So you're now ready to work on your homework, and as always, email me if you have any questions. All right, thanks.